Hello, welcome to the first lecture for the chapter 5 of Mathematics class 11, linear inequalities. So, we have heard before about linear equations and we have also seen how you can solve them. And there are quite a few algebraic operations that are associated with them. And obviously, it is useful to solve linear equations when you have to find values of variables. So these are the some things that we know about linear equations. So what is an equation? Equation is a statement where two mathematical expressions, values of two mathematical expressions can be expressed with equals to sign because we are considering them as equal. Okay, so are equal. So suppose you have x plus y is equals to any constant. Okay, so this becomes an equation. Okay, and if you have ax plus by plus c is equals to 0, this too is an equation. And suppose you have 3x plus 4 is equals to 5y. This too becomes an equation. Okay, so we know that two mathematical expressions, values of two mathematical expressions, when they are expressed along with an equal sign, an equal to sign, it becomes an equation. Now, we can see that, you can have different kind of equations. You can have two variables, or you can even have, we have learned about quadratic equations. Okay, so we have also seen a quadratic equation. Now, there are few equations which can be called as, they are linear in nature. Okay, so when do you call an equation as a linear equation? Is that when you, if you plot that function, in a graph, it should become a straight line. Why? Because actually we have the straight line equation. Okay, we also have a straight line equation, which is y is equals to mx plus c. Okay, and if you plot it in the graph, this actually becomes, comes like this. So this is your x-axis and this is your y-axis. So this is your x-axis, this is your y-axis. This is all your values of x and all your values of y. And this intercept over here is actually c, and the equation of this straight line is actually y is equals to mx plus c, where m is your slope of the line. Slope of line. Okay, so any equation which can be, represented in a form of a straight line would be a linear equation. Okay, so a linear equation graph is a straight line. Okay, so over here, since we have a y-intercept, okay, so a c. Otherwise, if your line is originating from, just say, origin, okay, so it's starting from the origin, so there is no c, since c is equals to 0, starts at origin. Okay, so this too is a straight line. So any linear equation, okay, so if you write this can be mx minus y is equals to 0. Okay, or y minus mx is equals to 0. So you can see this is in the same form as the, equations as we have, kind of given examples of over here. So this is a linear equation. Now, it's not always possible that when you express something, or even in some real life examples, we will see that everything is not, does not have an absolute value. There are a few, examples where you will have a range given to you, or there is certain limit that needs to be maintained. So even when you want to solve few physics problems, sometimes you will be given some conditions. Okay, and these conditions would not exactly turn out to be an equality in nature. Okay, so there will be some kind of inequality that is present. So what is a linear inequality? Okay, so we learned about the linearity of equations and equations. So when there are two values, mathematical expressions which are denoted by, or can be related to each other using an equals to sign. But in linear inequality, it is actually expressed with the help of symbols of inequality, but they do have a linear nature. Okay, so linear inequalities will still have a linear function. Okay, so that is, they too can be represented in the form of a straight line. Okay, so they do have a linear function, but they do not give equal relation between two variables, say. Okay. Then, as we said, it does not represent exact amount, but it represents a limit of what is allowed or possible. And the symbols of inequality. Okay, so for equal, we know that you have the equal to sign. What are some of the symbols that are specifying your inequality? Okay, so the signs of inequality are, so you have less than. Okay, so you have less than, you have greater than. Okay, these are the very basic symbols or signs of inequalities, but there are others too, like you have less than, or equal to. Okay, so over here we are saying, we are putting equal to, but there is also the other condition that it is less than. Okay, so it is denoted like this, and you have greater than or equal to. Okay, and that again is the, you put the less than or greater than sign and one dash underneath it. So these are the signs of inequalities, and we use them very we use them in the sense like we have statements like he got marks which are less than, or you can just say that Rashmi got less marks than Soham. Okay, so you are uh, giving a range. You can explicitly tell, obviously, you don't know the marks of Rashmi or your Soham. Okay, so you can think of one as X and the one as Y. Okay, so you can easily say that since we said Rashmi's marks, that is X, and Soham's mark is Y, we are saying that Rashmi has secured less marks than Soham. So you can easily specify this inequality in this manner. Okay, so this is what we kind of, represent, or this is what we are suggesting when we are talking about inequalities. Okay. So let's see examples of, as we said, we saw an example of when we are comparing the marks of two people. Now, over here, suppose the first statement is suggesting that Tanya spent more than 24. Okay, so first one, so let Tanya expenditure be X. Okay, now we are saying that she has spent more than 24. Now we do not know exactly how much she has spent, okay, but we know that the condition is given to us that she has spent more than 24. It can be 25, it can be 30, okay. So then it becomes X is actually more than 24. Okay, so this is how you uh, turn this statement into an inequality. Okay, 24. Now, the next one that we are having is children aged 10 and under are admitted to the concert for free. Okay, so let the age of each child be A. Okay, so for entry, the age of any child, okay, any child who is coming should be less than 10. Okay, so A should be less than 10 for the children to be admitted into the concert for free. So now we have established the second statement too in the form of an inequality. So that is A is less than 10. Now we were dealing with only one condition, or just a limit, either a larger limit or a smaller limit. Okay, so we were dealing with just one limit. Now in the last statement we are saying the ring is valued at more than rupees 1 lakh but less than rupees 3 lakh. Okay, so over here now we are suggesting that 3, let the cost of the ring be X. And again, okay, so let's just take X, or maybe we are. Okay, so now we are, let's write the limits as they have been given. So you have 1 lakh and you have 3 lakh. Okay, so there's a lower value and there's a higher value that we have mentioned. Now we can see that the cost of the ring we are saying is more than 1 lakh. Okay, so 1 lakh obviously. So R is going to be more than 1 lakh. Okay, so if we are trying to range, if you do not have this, kind of the 3 lakh limit that, or the condition that is being specified over here, then you could have just write, that R is more than 1 lakh. Okay, so okay, this could be your first condition, but less than 3 lakh. And the next condition that we are saying is actually R is more than 1 lakh, but it is less than 3 lakh. Okay, so your R actually comes in between your 1 lakh and 3 lakh value. Okay, so since over here, you can, if you have reversed uh, you have reversed the kind of, position of your variables, then your sign of inequality also changes. So in that way, 1 lakh is less than R and R is less than 3 lakh. Okay, so this is how such, double kind of conditions that you are given over here can be represented. So the third statement can be converted into an inequality in terms that 1 lakh or 3 lakh. 3 lakh. Okay. So this is how you can convert any given statement in form of inequalities. Now let's go into there are different types of inequalities. Okay, so this is easy for us to understand the how do we go about solving a certain kind of linear inequality also. So the first one that we will talk about is the numerical. So numerical is, as you know, it is easy to understand that you have absolute numerical values that are represented with inequality sign in between them. So you can have as 2 is less than 6, okay, and then the first okay. So 2 is less than 6, or you have 21 is more than 15, okay. So in these forms, whatever you have numerical inequalities can be represented. Now the second one that we have are literal inequalities. Now literal inequalities is that one of the values is an alphabet. Okay, so the variables that we represent in terms of alphabets. Okay, so you can have x is more than 3, or you can have y is less than or equal to 10, and you have x more than equal to 4. Okay, so these are called literal inequalities. Now, as over here, the first two, just excuse me, I have some water. Okay. So, till now we saw the first two types as we were saying. There are only two values, okay, and there is a sign of inequality that is present. But in the previous example, in the previous slide, the third example that we saw, okay, where your ring's cost was between 1 lakh to 3 lakhs. Okay, so when you have two such kind of, uh, uh, two values, or the middle value is between two ranges, that is called double inequality. Okay, so because now we mentioned inequalities but with respect to two different values. So for example, you have 2 is less than 4 is less than 8. Okay, so this is a kind of inequality, double inequality. Okay, and then you can have this is a kind of numerical in nature, as well as it's a numerical double inequality. But you can also have as 3y is less than or equal to 4. Okay, oh sorry, or no. So you can have it as that 4 is less than or equal to x, and that 2 is less than 9. Okay, so you can have, so what this would say is that x can range from say 4, 5, 6, 7, 8. Okay, so over here you can see, like, if we remove the if we only write this in the form of the less than sign, that 4 is less than x, the range would be from 5 to 8. Okay, but since we have put less than or equal to sign in between 4 and x, it starts with 4 but it still ends at 8, because we are still keeping the condition that the x would be less than 9. Okay, So this is kind of the change that you see if you whether you use less than or you use less than or equal to sign. Okay, so these are called double inequalities. You can have, another kind of 5 is less than y but equal to 11. Okay, greater than less than or equal to 11. So over here, this is 5 is less than y. Okay, so y cannot be 5. So the range will start, the y is greater than 5. Okay, so the values of y will not start at 5. It will start at 6, 7, 8, 9, 10, 11. Okay, so it will go up to 11 because we are saying that y can be less than 11 or equal to 11 also. Okay, so this would be the values of y, and over here these are the values of x. For numerical inequalities, you can see that there is no certain set of values for anything. Okay, so this is exactly given. We there is no way anything will change or anything will vary in the numerical double inequalities or in numerical inequalities. Okay, so now we have a few more types of inequality that we will see. So for that, let's write a few examples. Okay, so you have x plus 2y plus plus 2y incremental plus 2y is 3x plus 2y less than or equal to 12. 3x plus 2y more than or equal to 12. And we have x squared plus 2x plus 2 or 1 is less than equal to 0. We have x squared plus okay. So suppose these are few examples of linear inequalities. Let's number them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now out of these 10 equations, you can see there are a few changes. So in some of them, I have only put your less than or greater than sign. For some, I have put less than or equal to sign or greater than and greater than or equal to sign. Okay, I have also mentioned, I have also given examples where there is only one variable. There are few which have two variables, and there are a few examples where you have, quadratic equations that are given to you. Now, from these, you can see, for say equation, okay, so equations 1, 2, 5, wait a minute. Yeah. So 5, 6, 5, 6, and 10. Okay, so in these equations, we are only using only less than or greater than signs are being used. Okay, so you can, I'll just duplicate this so we can see different types of together. Okay, let's duplicate this. Okay, so let's take the first one. Okay, so as I'm saying that equations 1, 2, 5, 6, and 10. Okay, so all of these have either less than or greater than signs only. Now, what do these mean? These mean that, there is a limit which is mentioned. Okay, so there is no sense or there is no possibility of the values being equal to zero or the value that is mentioned on the other side of the inequality sign. Okay, so these have actually strict limits. Okay, so these have strict limits because there is no sign of, or there is no possibility of them still being equal to something. Okay, equal to the value that is mentioned. So these are called, okay, so 1, 2, 5, 6, and 10 are strict inequalities. Okay, so this is your first type of inequality. Now, the next one, we will see that in equations, say 3, 4, 7, 8, and 9. Okay, so for these equations, you can see that you have less than or equal to sign as well as greater than or equal to sign. Okay, signs used. Now, in this, you means that there is no strict adherence to the limit that we are mentioning. Okay, so it can be less than zero or equal to zero. Okay, or it can be, more than 12 or even equal to 10. So the limits are not rigid. You can say. Okay, the limits are not rigid. So therefore, these are called, so your equation 3, equation 4, equation 7, equation 8, and equation 9 are called slack. Okay, slack inequalities. So are slack inequalities. Okay, so that means that there is a possibility that there is some form of equality also present. So then we say that these are slack inequalities. They are not strict; they are slack inequalities. Okay, so the next one that we will see is, so from equations 1, 2, 3, and 4. Okay, so equations 1, 2, 3, 4, we are, mentioning in terms of one variable. Okay, and we have the inequalities that are present over here. Okay, so these are actually, and there is only one variable being used. Okay, equations 1, 2, 3, 4 have only one variable in x. Okay, so therefore these are linear, therefore called linear inequalities in one variable. Okay. They can be strict. Okay, so 1 and 2 are strict linear inequalities in one variable, and 3 and 4 will then be called slack linear inequalities in one variable. So similarly, okay, I'll just mention all the answer over here. Okay, and so if you now see equations 5, 6, 7, and 8 are then linear inequalities in two variables. Okay, because we have two variables. Okay, so you have x and you have y. Okay, and for equations 9 and 10, you can see very easily that these are in the form of quadratics. Okay, so you have quadratics. So these are quadratic inequalities. These are not linear. Okay, so they are not linear. They are quadratic in nature and they are quadratic inequalities. But since the chapter that we are dealing with is only linear inequalities, so we will only deal with linear inequalities. Okay, so there are a few rules that are existing. So for linear inequalities in one variable, okay, so suppose you have this as ax plus b is less than 0, or ax plus b is more than or equal to 0. Okay, so for such things, your a should not be equal to 0. Okay, provided a is not equal to 0. And similarly, for your linear inequalities in two variables. Okay, so for example, you have ax plus by more than or equal to c. Okay. Or ax, so ax plus by less than say c. Okay, so these will be linear inequalities provided a is not equal to 0 and as well as b is not equal to 0. Okay, so this is how we have linear inequalities, the types of linear inequalities. So you have strict, you have slack, and mostly like either you will have like one variable existing, or you will have two variables existing. Okay, now there are a few properties that are applicable while we are trying to solve linear inequalities. Okay, so for example, if you have for a linear equation. Okay, so let's consider a linear equation first. Okay, so because the properties that are applied on linear equation, they are similarly applied on linear inequalities also, with few exceptions and few changes. So first, let's see in linear equation. Okay, so in linear equation, if you have say ax plus b is equals to 0, okay, so you can add or subtract the same value, okay, or same integer on both the sides. Okay, so in that case, what you get or what we mean is that you can have ax plus b, say you want to subtract minus b from here and 0 minus b becomes here. this will be ax is equals to minus b. Okay, so in this form, okay, so you can do this. Or if you want to multiply both the sides of the linear equation, so you can even do that. So you have ax plus b is equals to 0. You can have 3ax plus b is equals to 3 into 0. So that again becomes 3ax plus 3b is equals to 0. Okay, so these are the similar kind of things that you can also do when we are trying to solve for linear inequalities. Okay, but the one rule does exist. We will see this, in detail later on multiplying or dividing by a negative. Okay, so the keyword is negative. Negative term, the inequality sign is reversed. Okay, so for example, if you have ax plus b is less than or equal to, say, c. Okay, and if you multiply it, or let's say if you want to divide it, so you have ax plus b by, say, 3 would also be c plus 3. Okay, over here you can see that the inequality the sign remains same. But if we divide it by, but if ax plus b by minus 3, okay, so and you have c minus 3, you're dividing both sides by minus 3. This is where your inequality sign will change. Okay, so over here changes. So this in way, how you can understand is that, suppose you have um, 3 is greater than 2. Okay, we know this. But if you add my negative sign, okay, on both the sides, so you have negative 3 and negative 2 over here. But as we know that, this is what happens. Minus 3 is less than minus 2 when we are considering, the negative integers or negative numbers. So this actually is what we are, trying to imply. This is what will happen if you have inequality sign in between. Okay. So the sign is reversed as you multiply or divide with a negative integer on both the sides of the inequality. So let's see a few more examples. Okay, we are kind of trying to see how we can kind of find it. Okay, so the statement that is given is that Anil has obtained 70 and 75 marks in the first two tests. Okay, so let's just write it. So he has got 70 and he has got 75 in the first two tests. Now he needs X marks in the third test to have an average of at least 60 marks. Okay, so now you can see the kind of the key words in the statement itself is that the average of the three test marks should be at least 60. Okay, so at least 60 is that the average of the three tests, okay, should be more than or equal to 60. Okay, so at least 60 actually means more or mm, or greater than or equal to 60. Okay, so you can write this as 60 and the third test marks is X. I'll just write it below. Okay, so the first test marks is 70, then you have plus 75, and then you have plus X. Okay, and the average of these should be greater than or equal to 60. Okay, so we have already said that when you say at least 60, it should be greater than or equal to 60. So you put your inequality sign, and that is 60. So this is how you can, we can get the statement in the linear inequality form, and then now you can solve it. Okay, so right now we won't solve it. We will do that after, we see some more rules, or there are step-by-step processes how we can solve for the inequalities. Okay, so the next one, we are seeing that Raj has 200. Okay, so 200 rupees is the total money that he has. Now he wants to buy some notebooks and pens. Okay, so let X number, uh, so let X be number of notebooks. Let Y be number of pens. Okay, now we can see that each notebook costs 50. So the number or the amount that he will totally spend on buying the the number of notebooks would be 50 into X. Okay, and similarly, so the total amount he will spend on buying pens, okay, on Y number of pens will be 15 Y. Okay, but now he cannot exceed the amount that is already given here. Okay, so his total expenditure, okay, of buying notebooks of rupees 50 each and of buying pens of rupees 15 each should be less than 200. Okay, so over here you can see we cannot say, equal to also. Okay, so we are not even trying to use the, less than or equal to. Okay. So otherwise, you can also think that, if it amounts totally to 200, if, if a condition is placed on this, that Raj has 200 rupees, okay, but he has to spend less than that only, okay, or the total amount can be equal to 200 also. Okay, because there is no other such condition said that he has 200 rupees, but he has to save 10 rupees. So if that would be the case, okay, so it would be if, he has to save 200 minus 10. Okay, so minus 10, so this would actually become your 190. Okay, so then it would be a 190. He will only be allowed to spend 190 rupees. Okay, then also we can have a slack kind of inequality over here. And over here also there is a slack inequality. But where does mostly what we deal with things are kind of, slack inequalities. Very few areas we, try to uh, solve or try to get, strict inequalities, that something has to be less than this. It cannot be equal to this. Okay. So some real life examples, as we have where you will see that, speed limits, you have to drive on a certain road below 60 kilometer per hour with speed only, or as we had seen before, you have age restrictions. Okay, so and say at certain places you have timings. Okay, timings, or you have kind of, weight limits, weight limits. So this is how, where you find the inequalities in the examples of inequalities. And sometimes you have to find some variable that is being used to express that inequality, and you might have to find the value of that inequality. Okay, so that is what's the entire concept of linear inequality and what we need to do. Okay, so we will end the class here today, and in the next class, we will try to solve different kinds of inequalities, and we will see how it is, how step by step we can solve linear inequalities. So, thank you so much.